Hello and welcome to another episode of How to Take Over the World with Basic Physics Concepts. Today's concepts will be concepts such as circuits, different kinds of circuits, AC/DC currents, capacitors, and resistors. To start off the video, we will be talking about different kinds of circuits. Circuits are anything that carries a charge from a source of power through a component and through conductive material, and makes a circuit back or completes the circle back to the battery through the components and through the conductive material. So the first circuit we will be talking about is the simple circuit. A simple circuit requires three things: power source, conductive material, and a component. The component can be such as a light bulb or resistor. The series circuit requires similar three things: power source, conductive material, but one or more different components. This can be a resistor and a light bulb and a light bulb, and a resistor and a resistor. The thing that distinguishes the series circuit and the simple circuit is the simple circuit is only one component. The series circuit can be multiple. When, as well, the series circuit has the same voltage measured across all the components. Now, onto the parallel circuit. The parallel circuit can be as many components as you would like or as you can fit on your power source, but each component is independently wired from each other. So it is basically a bunch of simple circuits all put together on the same power source. So if one circuit is broken, then only the circuit that is connected up to that one component is broken, which deactivates that one component. So if you have four light bulbs independently wired on a parallel circuit and disconnect one light bulb, then only one will go out and not all three. Now, the complex circuit. The complex circuit is just a circuit that cannot be broken down into a simple circuit, a series circuit, or a parallel circuit. So, it is as simple as that. Now, the difference between an AC current and a DC current is that an AC current is a actuating current. A DC current is a direct current. A direct current comes from a power source such as a battery, or it comes from a battery. AC current is a current that you would get out of a wall because it's safer and it travels longer distances from the source. The difference the difference between AC/DC is that direct currents are a continuous power supply. AC currents have fluctuations and they come out in bursts. AC currents actually have a frequency of 50 to 60 hertz, whereas DC currents have no frequency. Now, onto the components. The resistor impedes electron flow as to decrease the amount of electrons that continue on in the circuit. So, what this means is that if you connect a resistor between a power source and a light bulb, that means that the light bulb would be dimmer than it was before you connected the resistor into the circuit. And the capacitor actually stores excess electrons into its levels of metallic filling. It stores the electrons and stores them in a electromagnetic field inside the capacitor itself. And then when they are needed again, they will be released into the circuit. Now, you're probably asking, how can we use this to take over the world? Well, best time to talk about ray guns right here. Because what do you need to build a ray gun? Circuits. So, how can we use that? Well, let's just say this. You want to build a ray gun, but you're not going to do that. The best you can do is spray paint a taser and say it's a ray gun, because that's what you're going to do if you do not know about circuits. Using a circuit, you can connect the trigger to a battery to a discharge unit. So just say you were making some sort of electricity weapon. From there, you could connect the battery to the trigger. The trigger completes the circuit, and which the discharge unit, or whatever you choose to use to discharge energy, would then have energy fired from that unit, which would then hurt your enemies. It would hurt Bob. Still don't like Bob. Haven't met him yet, but we don't like him. And then what else we could do is switches. We are mad scientists. We love our switches. I personally love the big throw the switch, connects up, electricity flies, and then your evil contraption is burst into action. So if we didn't know about circuits, then we couldn't have the really cool switches, because all that is it is completing the circuit between a power source and whatever else it is connected to. So say you just want to bring your undead monster back to life. That's not going to work unless you throw the switch, which completes the circuit and allows the electrons to flow through the monster, reactivating its brain and reanimating it. Pretty cool stuff. Well, I'll see you next week, since you guys will still need me, since no one has taken over the world. And that hope is just, it's going away pretty fast. Thank you. Have a good night.